So in total, you will have 9 electrons, 9 orbitals in maximum, and each orbital can occupy by 2 electrons. That means in total, you can accept 18 electrons. So in the central atom from the third row, the bottom, it can get more than 8 valence electrons. For example, for the case of sulfur. In the case of sulfur SF6, you will see that the sulfur will have not only an electron, but it has 12 electrons, right? So in that case, if the molecule has non-bonding electron domain, then it will occupy the equatorial position. Equatorial position is this one, this one, and this one. Axial position is this one and this one. So if the compound have non-bonding electron domain, the non-bonding electron domain will be occupied in the equatorial position, but not in the axial position. So we will occupy this position,
Con rồi.
this position, or this position.
Build kiểu gì? Thì vậy con Raiden C2 nha.
Do you understand why?
Và có cả đi lắc.
Because if you have non-bonding electron, the interaction will be stronger than the bonding electron,
Không, ý
right?
là sắp pin cơ.
So they should prefer the position where the distance
Pin chơi với đi lắc.
between
Người
non-bonding
ta tiếp theo
electron
còn
domain
nữa.
will be longer. So the angle bigger is better. Okay? So for example, in this case, you have this angle in the equatorial will be 120. Okay? So it's far compared with if you have here, the angle will be only 90. So the concept, the key is that
Và
stabilization of the system by minimizing the interaction. So the electron domain gets further, longer, so they prefer to occupy by the equatorial position, not axial position. Okay? So here, few cases. If you have one electron domain, you will have
mình
structure
đã đưa ra cao phải nó rồi.
geometry. You have a linear, but you have 3 electron domain that you occupy the equatorial position. And here you have a B3, and the 2 electron domains occupied in the equatorial. So basically you have T-shaped molecule. Okay? So basically you will see that normally the T-shaped molecule will be not very favored because the angle between A, B, and B will be only 90 degrees. Okay? And so the tendency is that they will expand the angle bigger than 90 degrees. However, because they have non-bonding electron domain and non-bonding electron domain prefer to occupy equatorial, so all the other atoms that need the bonding electron domain have no other choice than arrange to be T-shaped. Even T-shape is unstable, but unstable compared with the square planar, okay, or triangular, but is more stable among themselves. Okay. So for the same here you have. So here you see that there one case is all the case here you see. You see some like when you quick look like confusion, right? I mentioned that the electron non-bonding electron domain prefer to occupy the equatorial, but not axial. But here you see that it occupies the axial, right? And here also axial. But actually, because you talk about the octahedral, so octahedral is exactly the same in four direction, right? So this position and this position or this position, they are the same. So if you have one non-bonding, it's occupied only one of the six, right? And here they occupy two positions. If you look like this, it looks like equatorial. Axial, right? However, if you turn, it becomes equatorial. So there, yeah. So let's say, okay. Then it becomes equatorial. So quickly look. If you have a quick look, it looks like confusion, but it actually is follow exactly the rule. Okay. Now, if you have one molecule or bigger molecule, large molecule or bigger molecule with smaller molecule, sorry, several atoms. First, you find the interior atom. That means the atom inside the molecule in between. Interior, for example, this one we call the interior atom. This one we call the terminal atom. Terminal atom at the end of the molecule, right? So the interior atom 1, 2, 3, and this atom, this one, and this one we consider like terminal atom. The atom at the end of the molecule we will consider. So we consider the interior atom 1, 2, 3. Okay? And then we predict the geometry of X interior atom. You are not able to predict the geometry of the whole molecule. You predict the geometry of X interior atom. Okay? So here, and here, let me see what will happen. So here the molecule, one interior atom, second, the first one. So the first one, you will have theta hero, right? This one, you will have 1 electron domain, 2, 3, 4 electron domain. So it will make a theta hero. The second atom here, you will have 1 electron domain, 2 electron domain, and 3 electron domain. So it will make a trigonal diagram. And the last one, you will have 1 electron domain, 2 electron domain, 3 and 4 electron domain. Okay? Including among 4 electron domain, you have 2 bonding and 2 non-bonding. Okay? So in general, it's made theta hero. But if you look only the carbon, oxygen, hydrogen, it will have band structure. Right? So, please use this model to predict the molecule geometry of PF5 and PF6 minor. Can you work on that?
Tí nữa là tao học tu thu hóa là bài tập 7 đến 11 đấy, là thầy đang dạy, có nghĩa là cả lũ không đứa nào làm được.
Ngày chưa có bài tập đúng không? Thì ngày mai tự làm đúng không?
Không làm được luôn. Đây, nó hỏi nhé, nó hỏi tại sao cái này không làm được, có mẹ mày. Đây như này, nó hỏi tại sao cái này là đường thẳng, cái này là cong. Đấy thì đang học mà. Thực ra là tôi bỏ lỡ rồi đi. Vui không? Hoặc là mai tôi đến tôi học cùng lớp A, hoặc là tôi không đi. Tôi nghĩ là tôi nên đi để tôi có hiểu. Thế này. Chết.
So, done already?
Mấy giờ rồi? Mà tôi nó rất buồn ngủ kể bạn. Ê, dây đi.
Không có dây.
Thì mày cắm vào đây.
Mày điên à?
Sao? Mày thay pin rồi mà gì?
Không lắp pin à?
Hả?
Tao không lắp pin.
Thế thì xả thế. Sao mày lại không lắp pin? What the fuck?
Tao vứt pin ở nhà.
Tại sao vậy? Kỳ gì vậy? Không của mày. Đúng. Mày điều chỉnh sạc thằng kia thế nào mà nó ra được chỗ tao ấy. Sạc nó chưa thấy cỡ. Mày nhìn lại đi. Chưa thấy cỡ.
Hết rồi.
Nào. Ôi. Mày kéo dịch cái cục sạc của nó. Thế.
Nha.
Đặt cái cặp của tao ở đây. Tệ quá. Tệ quá.
Con rơi. Bên nên cầm con kiếm nào được? Tiếng hét. Ồ. Có luôn.
Okay. Let's reboot together.
Con này cầm tài hay là
Okay. BF5 is quite similar and quite easy. So phosphorus, how many valence electron you have? 5, right? Phosphorus, sorry, fluoride, you will have 7. So 6 times, right? So if you take BF6,
không còn đấy lấy rồi.
you will have 47 electrons. If you take BF6 minus, that means 47 plus 1 electron equal to 48 electrons, right? Is it correct? Now,
Con này cầm cái đéo nào?
you put phosphorus in the middle,
Cái của đồng tập người được.
2, 3, 4, 5, 6, okay? And then you put the single bond, X single bond corresponding with 2 electrons.
Mẹ tay rồi dòng tương long tích khác.
Next step, you complete the octet loop for the fluorides. Here, 8, 8, 8. Okay? Is it okay? So, 1 get electron, next. So it does 1, 2, 3, 4, 5, 6. 6 times of electron equal to 48 electron. So exactly the total electron you have in the anion. Okay? So you have no more electron left over for the phosphorus. And because of this is one anion, so you put like this. Okay? Because you have one negative charge on the compound. Now, if you look in the phosphorus will have 1, 2, 3, 4, 5, 6. So the phosphorus will have 6 times 2 equal to 12 electrons. It's different than 8 electrons. But if you look in the periodic table of element, phosphorus is in the third row, right? The second row is nitrogen. So it means if you put nitrogen here, the compound doesn't exist. Okay? Because nitrogen can only accept 8 electrons. Because nitrogen have only S and P orbital. But phosphorus, you will have S, P, and D. Okay? So if you talk about the compound NF6, the compound will be not exist. Okay? But PF6 is allowed even you have more than 8 electrons because you have orbital ring. Okay? Now, if you want to look for the geometry, you have to calculate, you have to look how many electron domains does a proton have. 1, 2, 3, 4, 5, 6. So you have 6 electron domains. Okay? So if you want to arrange 6 electron domains in the 3-dimension geometry, it could have so you have this octahedral. Okay? So the compound, the geometry of this compound will be octahedral. So that's the way we view we predict the geometry of one compound, one atom, or higher in general. Is it okay? So we do step by step. Okay? Otherwise, you have another choice is remember. So remember everything. Otherwise, we do by this way. Okay? So here is the F5. So you have trigonal pyramidal geometry. And here you have the F6. You have octahedral geometry. Okay? And of course, the angle between the fluoride, phosphorus, and fluoride will be 90 degrees. And you can see that the interaction between fluoride to fluoride is quite short. So, if you have one chemical reaction, what would be the tendency? The tendency of this compound will be removal of this one fluoride. Because the interaction will be very short, so they try to decrease the interaction by removing one fluoride. And if you remove one fluoride, the remaining fluorides here can get far from the atom center. So when it gets far, the distance to this one will get longer, so the interaction gets weaker. Okay? So that's the way to make it. Now we move to the next part, molecular shape and molecular polarity. In the previous lecture, we already talked about the bond dipole, right? That the dipole moment is only to the 2 atoms in that bond. That means because of the different electronegativity between the 2 atoms in the bond, right? If you have 2 atoms with different electronegativity, you have a polarity of this bond. Okay? And so here you have carbon and oxygen. They have a different electronegativity, so you have bond dipole, right? So normally the dipole, you put the arrow direction from the lower electronegativity to the higher electronegativity, representing the way that the higher electronegativity attracts electrons. Okay, so that's the concept. And then when you put the two bonds in one molecule, depending on the geometry, we talk about the dipole moment of the molecule. So the dipole moment of the molecule will depend both on the polarity of the individual bond and the geometry of the molecule. Okay? So for example, you can see here, the carbon-oxygen bond is polar, right? Because carbon and oxygen have different electronegativity. However, because of this linear geometry, so this vector and this vector will be suppressed. So the total of the two vector will be 0. So that means X bond is polar, but the molecule itself is non-polar. And if you take the molecule water, you will see that you will have one bond dipole, and because the molecule is band structure, band geometry, so you make the total of the two vectors, it will be different than 0. Okay? So this compound become polar. Okay? So you can see that the higher value of the dipole moment of the molecule, higher polarity of molecule will be. Okay? It means the total vector have a larger value in terms of diverse value, then the molecule become more polar. So what we can learn from here? CO2 is non-polar molecule. Water is polar molecule. So it means that CO2 have very low solubility in water. Okay? So we learned that polar compound will be soluble in the polar solvent, and non-polar compound will be soluble in the non-polar solvent. Here you have CO2 is non-polar and water is polar. The solubility of CO2 in water is very low. Why? When you burn gasoline, you generate CO2. CO2 will remain in the atmosphere, but not soluble in the seawater. Okay? Is it correct? Because of the difference in terms of polarity. So, you can do a simple exercise. Which of the following molecules are polar? So here, you have two atoms with two different electronegativity. So, we talk about the bond dipole moment, right? So this compound is polar. This compound, the bond between the fluoride and chloride is polar, but because it's already in the triangle like this, so if you take the total vector of this one, you will have this, and this will subtract this one, right? So the total vector of this compound will be 0. So this compound is non-polar. The same for this one, it will be non-polar, and this one will be polar because you have three similar items, but this one, the vector will be different. So if you take vector by vector addition, you will have the total vector of this compound different than 0. The same for the molecule Na3 is also polar. So it means if you take this compound, it will be soluble in water. This compound is soluble in water, but this one not. Okay? This one, because of dipole moment is not very strong, difference than 0, not very high like water. So the solubility, this compound can be soluble in water, but with low solubility. The amount of this compound dissolved in water is low. Okay? And of course, this compound will be not soluble in water. So now, question. Which of the following molecule is or are polar? A, none of them. A, all of them. B, none of them. C, octo and meta. D, meta and para. And E, octo and para. Which one will be the correct answer? A, B, C, or D? E. So basically, in this calculation, you would have only one correct answer. What would it be? What could be the correct answer? So the correct answer will be So the correct answer will be C, right? Octo and meta, because the para, if you take the addition of the two vectors, it will be 0. Okay? Okay or not? is polar or apolar.
Vì tiến hóa thì khó chứ để chạy ra để đủ các đề cản tiến hóa. Nhưng mọi người chậm
So let's we go through one by
Bên
one.
trái xem nó làm từ 77 đến
A,
311.
whether it's polar or non-polar. Polar, right?
Nó chưa làm
B, polar or
Lúc này vì
non-polar.
thêm một lúc nãy khỉa tao đập
Huh?
mẹ.
Non-polar, right? Because it's like CO2. SO3, polar or non-polar? Non-polar. PCl3,
phim hàng thì
polar. SF6, non-polar, right? IF5, polar or non-polar? So this one, and this one are non-polar, right? PF3 or PCl3 or IF5 will be polar. This compound have this geometry because you have one electron domain here for the outline. Okay? When you turn on the television, you will see the advertise about nanococumin, blah, 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 right? The thing is that this is molecule curcumin, and you see that this compound is quite symmetric, right? If you put a linear here, knife here, you will divide the compound by two halves. This half and this half exactly identical. So basically, this compound has low polarity. And if you have low polarity, low solubility in water. So one of the questions for you guys to study at home is that how can we make this molecule curcumin, which is low soluble in water, become higher soluble? I mean, to make a higher solubility of this compound in water. So let's try to put it. Now, we move to the last part. We talk about covalent bonding and orbital overlap. Imagine that you have two atoms, right? And each atom have one atomic orbital. So here in the orbital, you have nucleus with positive charge and you have an electron negative charge, right? So the second orbital will be the same. So you have different interaction. Negative charge, they will try to repel, right? However, the electrons of this atom will be attracted by the nucleus of this atom and then inverse. So the two atoms try to get closer, and then at one moment they will stick together, and then the two orbitals will overlap. Okay? However, they cannot, after overlapping, they cannot get too close because when the distance between two nuclei gets shorter, the repulsion will be stronger. So you will bring a kind of balancing between attractive force and repulsion force. So basically, you will have this overlap of the two atomic orbitals, and the area we overlap, we call the overlap region. So here you have S orbital and S orbital overlap. You have S orbital and P orbital overlap, and you have P orbital overlap, right? So, imagine that you take two atoms with a distance far from each other, okay? They become like two independent atoms without any bond. Okay? Then the energy, here you have energy, and here you have the distance between the two atoms. Okay? So if you have this distance, that means the two atoms get far from each other. So you have a total energy, which are the energy of two atoms. Okay? So when the two orbitals get closer and you start to have overlapping, the energy of this system gets at this level means decreasing in terms of potential, in terms of energy. And when the energy decreasing, it means that the system becomes more stable. Okay? And if you go to this position, so the overlapping will be maximum, we will say like this. And then here the energy will be minimum. The energy minimum, that means normally the molecule hydrogen will stand here. So the distance between the two hydrogen, where the energy is minimum, we call that is bonding distance between the two hydrogen. Okay? If the two atoms get closer, that means it goes to the distance by this position, and you will see that the energy increase. That means now the system gets repel each other stronger and attractive. So if you go to this distance, the energy becomes too high, that means the system cannot be stable. Okay? So when you look at this diagram, you can understand following thing. When you talk, thus the molecule hydrogen have a distance of 0.7 angstrom. That means at this bonding distance, the energy of the system N2 is minimum. Okay? And this state, the hydrogen state here, we call the ground state. Okay? The lowest state, we call the ground state. Okay? However, it doesn't mean the molecule hydrogen can stand only at this distance. It can stand at this distance, and so on. So basically, the molecule hydrogen can stand here, here with different distance, here with different distance, and here different distance. And when you change the distance between the molecule of two hydrogen, you change the energy. Okay? And when you go to this distance, the energy increase, and at this point, you cut the bonding. You dissociate the bonding. Okay? So now you have two atoms of hydrogen. Here, that's the distance 0.7 angstrom, where you have a minimum energy. But it doesn't mean that hydrogen all the time stands at 0.7 angstrom. Okay? It is ground state, most stable state. But it can accept this distance, still the bonding in between, longer, so the energy increase. Okay? And it can go to this distance, energy increase. Or in short, in other words, it can get shorter distance and the energy also increase. Okay? So it means that if you have 0.7 angstrom, the energy will be minimum. But each time it's moved like this, it will make the energy system up, down, up, down, up, down. Okay? So it means that if you have molecule hydrogen, this energy, this and you heat the system, okay? That means you put energy to the system. The molecule hydrogen will absorb energy you put inside, right? By the conservation of the energy law, the system will get increased to the higher energy level, right? So at least when you put energy, you move to this system, this position that you have. Okay? It means that if you keep molecule hydrogen at 0 Kelvin, okay, there are no movement. The distance will be over 7 angstrom, absolute. Okay? But then you start to heat it, the system will be moving. And this can accept, if you put more energy inside, the moving will get longer, and then it go up higher energy level. Okay? So basically, we understand that lowest level means the most stable one. 0 Kelvin, absolute, okay? But when you put energy in the system starts to vibrate, okay? And when it vibrates, it can change in terms of the distance. And when you change the distance, that means you have one in some period of time, the electron will not look like penetrating the one atom than another one. So you create the polarity. Okay? So more you make the system vibrate, at one moment you put very high energy to the vibration, this can dissociate the molecule hydrogen. Okay? Is it correct? So you remember that the molecule hydrogen can have several energy levels. Molecule of hydrogen, not atom hydrogen. Molecule of hydrogen can accept several energy levels. And each energy level is corresponding with what distance between the two atoms. Okay? And you can change the distance between the two atoms. That means you can change from one energy level to another energy level if you put energy inside or if you take energy out. Right? It means if the two atoms are higher, the longer distance, the higher energy, if you take energy out, it will back to the lower energy level. So it means during the vibration of molecule hydrogen, the molecule hydrogen can absorb energy and can release energy. Okay? And the energy corresponding with the excitation from one level to another level, from B level to B level, corresponding with the long wavelength of about 1,000 nanometers is in infrared region. In the red line. Okay? So that's why now at home, okay? At home, when you in the bathroom, right? In the bathroom you have halogen lamp, right? And when you turn on the lamp, you see the red color, right? Is it correct? You see the red color light, and the red color light corresponding to the infrared photon. And infrared photon can make the molecule water in the air vibrate. And it vibrates, it releases energy, so it increases the room temperature. Okay? So that's the reason. If you want to warm up the bathroom temperature, you turn on the red light, halogen light. Right? Because you will excite the vibration of the molecule in the air. Okay? Understand it? Okay? So if you buy the white light, like this one, okay? You put in the bedroom, the took charge at the room temperature. Because the visible light will be not yet make the molecule excited by vibration. So the molecule will not vibrate too fast. So in that case, the temperature will not increase. Okay? So you see, if you can come back home and you check all the light, maybe the red light. Okay? So sometimes you take a cup of coffee and you can imagine several things. Beauty of the chemistry as follows. You see this, right? What it is? Right? Tháp sóng giống, ok? Là người Việt Nam đến chết tháp sóng là kết. Phần về đến chủ sống của họ. Okay? Tháp bản thân vẫn là phun. So the concept of water flow is that the energy will fall down on the higher energy level. So anything you put at higher energy level is will spontaneously go to the lower energy level. Spontaneously, like water. However, we are talking about using not gasoline but hydrogen to run the car. And if you want to run the car with hydrogen, you need to do this chemical reaction. So hydrogen plus oxygen to produce water. Okay? And this process is downstream process. That means the oxidation of hydrogen plus oxygen is exothermic reaction. By the principle like waterfall, exothermic reaction will happen spontaneously. However, if you want to run the car, like in fact you want to run the hydrogen car, so this is Toyota hydrogen car. Then one of the big challenges is to make this We are talking about hydrogen. So hydrogen is one, right? So we are talking about this. Okay? So here you can see hydrogen. And of course, by the same concept, the molecule water will have also more energy, right? So here is molecule of water. Okay? What if we are saying from here to here, like from the top to the bottom, is we are talking about deep level and deep level. And if you look only at the level of energy, we say that from the top to the bottom, it means fundamental. So if you go from here to here, it should like a waterfall, right? However, the chemical reaction do not happen like this. Because the molecule hydrogen stand here, it's not only unique energy level, it's like in the chart. Okay? So if you want to make hydrogen jump from the water, you need to bring hydrogen here up here. Okay? So if you want to bring up here, and then it falls, so this energy level, you need to push in. So if you don't have this energy, you cannot bring the hydrogen up, then the reaction cannot happen. Okay? So that is the concept of this curve. Not only hydrogen have this curve, but all the molecules will have this curve. So because this curve, so later when you learn the general chemistry too, you will learn about the activation energy. So activation energy is the energy from the water to somewhere up and then it's full. Okay? So that's important with a cup of coffee you can figure out this very beautiful concept. Okay? So imagine us, if you want to make the reaction, so activation energy change, what you can check is that you will not accept this way, but you check the pathway by this way. So you load down the activation energy, you make the reaction happen easier. Okay? But you will learn about this in general chemistry. But what I want to say is that this fundamental curve is extremely important if you want to understand the chemical reaction. Otherwise, the concept of activation energy for some time is quite difficult to imagine. Okay? Then, if you cannot imagine, you cannot understand well, you try to remember. And most of the time when you try to remember, you forget. Okay? So, the last thing, we talk about the hybrid orbital. The thing is following. We talk about the overlap of the two orbitals. Okay? So, if you take the case of the carbon have orbital S and orbital B. Okay? And then, if you make the carbon with hydrogen, for example, right? So hydrogen have only orbital S. So if you take carbon have one orbital S and three orbital B, right? So you can say that when the carbon bond with four hydrogen atoms, it will create at least two different kinds of bonding, right? One is between orbital S of the carbon with the orbital S of hydrogen. The second is between the orbital S of the hydrogen with the orbital P of the carbon. And because orbital S and orbital B, they have different in terms of shape, different in terms of symmetry, different in terms of energy. So you would expect that the same carbon bond with four different hydrogens. Okay? Is it correct? One with S, three other with P. However, when you look at the carbon of CH4, methane, four hydrogens are exactly identical. So how can we explain this phenomenon? The overlap of orbital S, P, S, S is your imagination. It's not the Gauss shape. Okay? The Gauss shape in the case of CH4, four hydrogens will be identical. If you are not able to understand, that's your problem.
thử xem với tôi đúng không?
Okay? So your problem is saying that, okay, I have an orbital S, I have an orbital S, you have an overlap, and orbital S, and orbital B, you have an orbital SP. But then you are not able to explain the simple thing, which is 4 identical carbon hydrogen within the CH4. Okay? So how we deal with this? Here is not the wrong phenomenon in the nature, but your limitation in understanding. Okay? So to fill the gap between your understanding and the real in the nature, they propose the concept of hybrid orbital. Hybrid is means you take the S, you take the B, you mix, you will have orbital SP. Okay? And the orbital SP will contain both the character of S and the character of B. If you take one S, you mix with one B. Okay, so I have to go now. It's urgent appointment. So we stop here. We'll see later in the next